Hello everyone. In this video, we're going to be looking at SUVAT equations. Mind you, this is not an absolute beginner video and therefore it is for people that are well aware as to what SUVAT serves the purpose of. And therefore, with that in mind, we'll be covering the following in the video. First, being the basic questions. So these are warm-up kind of questions in order to prepare us for the final question which I've set. So basic questions, there will be 3 questions, each with a timestamp in the description below. So this is just warming us up in order to do the ultimate one, which is the IB question. Knowing that this channel is dedicated for IB students who are willing to further improve their skills in the IB diploma, I have created one particular question from the IB question which has multiple parts, and so that'll be concluded at the end of the video. So the first and most basic question is that a particle is accelerated uniformly from rest, so that after 10 seconds it has achieved a speed of 15 meters per second. Find its acceleration and the distance it has covered. So just to make this more simple and not too out of place, I have also put in the SUVAT equations, which will be used, and these are provided in the IB formula booklet, and therefore no need for memorization specifically for IB students. And if you'd like to attempt it on your own, you can go ahead and pause the video. But let's get started. So first, what I'd like to do when I'm given a question is to note down given information. So given information, we see that a particle is accelerated uniformly from rest. So initial speed is 0, so that after 10 seconds it has achieved a speed of 15 meters per second. So we know time is equal to 10 seconds, and final velocity is 15 meters per second. Find its acceleration and the distance it has covered. So our goal is to find A and S. So a well-rounded question overall. So let's start by finding A. If we look at the first equation, we are seeing that velocity, initial velocity, acceleration, and time is included. And since 3 are known and 1 is unknown, we can go ahead and use the first equation. So I'll just write down the equation here so people are aware of what equation I'm using. So final velocity is 15, initial 0. Acceleration is what we're trying to find. And time we're given as 10. So we get 15 equals to 10a. And so acceleration is, I believe, equal to 1.5 meters per second squared. So now let's try to find displacement, or distance traveled. So if we look at the last formula, S equals to V plus U times T over 2, we can go ahead and use this equation. So we can do S equals to V, which is 15, plus U, which is 0, multiplied by time, which is 10, over 2. So we get S actually is equal to 15 times 10, which is 150, divided by 2, which then we get as 75 meters. And so the distance traveled is 75 meters. Now, the second basic question. Again, like I said before, I'd like to first wrap up and know what given information there is. So if we look at this, a car accelerates uniformly from rest, and after 12 seconds has covered 40 meters. So uniformly from rest means that its initial velocity is equal to 0 meters per second. And after 12 seconds, it has covered distance of 40 meters. So t is equal to 12 seconds, and s is equal to 40 meters. And the question states, or asks, for its acceleration and final velocity. So the first one does not work, but the second one, however, does work. So we're going to plug in the values for the second one. So 40 equals to ut. Since 0 times anything is 0, we just exclude that, and we get acceleration times time, which is 12 squared divided by 2. So we get at is equal to 144 acceleration. So acceleration is at divided by 144, which is equal to 0.56 meters per second squared. But now, what about final velocity? So we're given acceleration, displacement, time, and initial velocity. So if we look at the first equation, final velocity equals to initial velocity plus acceleration times time. We can go ahead and use this equation as it's very simplified and efficient. So final velocity is equal to initial, which is 0, plus acceleration, which is 0.56, times time, which is equal to 12. So final velocity is just 0.56 times 12, which we get as 6.67 meters per second. And so we have done the second basic SUVAT question. Moving on to the third one. With the third one, again, using the given information, we're going to deduce what we can find. So a train is accelerated from 1 meter per second to 5 meters per second over a distance of 15 meters. So we're given u as 1, we're given final velocity as 5, and we're given s as 15 meters. We have to find acceleration and t, time. So the first equation, there is no time given. So that means we have to find an equation that does not include time, which is only the third one. So we're going to go ahead and use that. 5 squared equals to 1 squared plus 2 times acceleration, which is what we're trying to find, times displacement or distance. So 25 equals to 1 plus 38. So we move 1 to the other side. So 24 is equal to 38. And so we get A is equal to 24 divided by 30, which is equal to 0.8 meters per second squared. And now we're going to try to find time using the given information. So this includes final velocity, initial velocity, displacement, and acceleration. So to find time, we can go ahead and use the last equation, as this provides displacement, initial, final, and time, which we all know the information of. Or we can also see what the first one does, which is final, initial, acceleration, and time. So we can actually go ahead and use the information we found to make it faster, which is exactly what we will do. So 5 equals to u, which is 1, plus acceleration, which is 0.8, times time, which is what we're trying to find. So we get 4 is equal to 0.8 t. And if 4 divided by 0.8, we get t is equal to 5 seconds. And just like that, we have solved the third basic SUVAT equation. So now we're just going to go ahead and begin with the SUVAT equation, or SUVAT question from the IB diploma, as this is the entire purpose of the channel. It is to help people understand exam solve questions for physics, math, and other subjects dedicated. So let's go ahead and attempt this. As a heads up, if you had struggled with the basic SUVAT equations, the 3 questions prior to this, then I recommend that you further improve your own understanding on SUVAT equations before attempting this question, as this is a lot more advanced than the previous questions that we have seen. And hence, it is to let people know exactly what exam style questions are like. It is tough, but understandable as we go through it. So let's start. This question is about throwing a stone from a cliff. So right away, we have to know that this is a free fall question. So this is important to consider. So let's keep that in mind. It's a free fall question. So just going to go ahead and keep that in mind. So Antonio stands at the edge of the vertical cliff and throws a stone vertically upwards with v equal to 8 meters per second. The acceleration of free fall, g, is 10 meters per second squared, and all distance measurements are taken from the point where the stone leaves Antonia's hand. Ignoring air resistance, calculate the maximum height reached by the stone. Okay, as I mentioned, it is a free fall question. So we're going to have to, as I said, take into consideration g as 10 meters per second squared. And we also know it leaves her hand with 8 meters per second. So the information we're given is that initial velocity is equal to 8 meters per second, and gravity is 10 meters per second squared. But since gravity goes down and this object is going up, it's actually going to have negative gravity. So we're going to go ahead and say it's negative 10 meters per second squared. And it says the maximum height reached by the stone. So this is definitely not valid information, but there's one more point that we can deduce from this, which is that final velocity is equal to 0 meters per second. Let me explain. So we're having a person, which in this case is Antonia, at the edge of a cliff. She throws a stone up in the air, which let's assume takes the following track. And this is the maximum height achieved. when it is at maximum height, the object is at rest, which is the final velocity, and hence we know that velocity is equal to 0 meters per second. So the maximum height is when the final velocity is 0. And so we can deduce now 3 different measurements, and further helping us to answer the question. So time is not provided. So we're going to have to find an equation without time, which is the third equation, v squared equals to u squared plus 2as. So we're going to use the equation without, which is the third equation. So v squared equals to u squared plus 2gh. But since we consider gravity as negative, we're actually going to rewrite this as v squared equals to u squared minus 2gh. So this is to make sure that this is actually applicable in this scenario. Now, if we were to rewrite this, then we would get h is equal to u squared minus v squared over 2g. So we get h is equal to 8 squared, because velocity squared is just 0. So 8 squared divided by 2 times 10, which is equal to 64 divided by 20, which is equal to 3.2 meters. And so we get height max as 3.2 meters. Now we're going to go ahead and see how to do A2, the time taken by the stone to reach its maximum height. So we know that g in this case is negative 10 meters per second squared. And we also know that final velocity up there is 0 meters per second. And the distance traveled is equal to 3.2 meters. And along with the fact that u is equal to 8 meters per second. So using all this information, we can go ahead and plug in the values for a formula which seems applicable in order to find time. And the most suitable one seems the first one, v equals to u plus at. So if we go ahead and plug in the values, so v equal to u plus at, in this case it would be minus gt, so 0 is equal to 8 plus but minus 10t. And now if we rearrange this, we get t is equal to 0.8 seconds. So let's go ahead and sketch the situation in hand. So we're given that Antonia is standing over here and she chucks a stone like so. And from chucking the stone to this point, it takes 3 seconds. And they ask us to determine the height of this cliff. So what we are well aware of is that from here to here, it's this time minus this. So 3 minus 0.8, which is equal to 2.2, is the time it takes from here to here. So now we're going to take the new t value as 2.2 seconds. Now, we know that we're going to take this as a different situation with this point. So we know that u is equal to 0 meters per second from the previous information that we had gathered, that at that maximum height, velocity is 0. So u is equal to 0 meters per second. What we also know is that g, this time, equals to positive 10 meters per second squared. Because the object is going downwards along with gravity, g will be positive. What we also know, the final one, or what we want to know, is displacement or distance. So we're going to go ahead and find a suitable formula. The formula that seems most suitable is the second one, s equals to ut plus half at squared. So if we go ahead and write this formula, s equals to ut plus gt squared over 2, we can plug in the values and actually find what s is. So s, because u is just 0, we get s equals to gt squared over 2. We plug in the values, 10 times t, which in this case is 2.2 squared, divided by 2. We get this answer as 24.2 meters. But this is the height from here to here. But we just want this. So what we're going to do is we're going to take this entire height and subtract it by this height, which we found in the first part, 3.2. So now if we go ahead and do 24.2 minus 3.2, then we get our answer as 21 meters. So the height of the cliff is 21 meters. Thank you guys for watching this video. Hope you learned something new